Hello, in this video, I will explain to you on how to solve this problem. Number 4. What is the internal resistance of 12-volt car battery whose terminal voltage dropped to 8.2 volt when the starter motor draws 95 ampere? What is the resistance of the starter? Okay, because this is a physics problem, we should always draw it, right? Let's draw the circuit here. We have an car battery here with the EMF of 12 volts. So the long one here is the positive terminal and the short one is the negative terminal, and we have the EMF of 12 volt, and then we will have its internal resistance, right? So we will have this here. Let's name this internal resistance as small r, okay? And then it's connected to a starter, and it also have unknown resistance here. So we will have this as capital R, right? So the capital R is the starter resistance, and then the small r is the internal resistance of the battery. So we have this is our battery, right? This is our battery, and then when it starts, okay, it has a current of 95 ampere. So here, because they are in series, so we will have all the current are the same. So we will have this I here is 95 ampere. Good. But then when it is 95 ampere, the terminal voltage, which is the difference between this node here and also this node here, that will be 8.2 volt, right? So this one will be 8.2 volt. However, if you see here, this is in parallel, right? So we can also use this value here to calculate this R here. So how to do that? Let's use the Ohm's law, right? So I will have V is equal to I times R. Okay, the R here is only this one. So we will have our 8.2 is equal to 95 and then multiplied by R. And then we will have R here is equal to 8.2 divided by 95. And that is, okay, let's see here. We'll have 8.2 divided by 95. Okay, and I will have 0.086. Okay, we'll have 0.086. Yeah, 86. And the unit here will be in ohm. Good. Now, what can we do from here? Look, the terminal voltage is this one here. So if we see from the terminal voltage, okay, terminal voltage is 8.2 volt, right? But then that 8.2 comes from 12 volt, and then there will be a voltage drop by this resistance here, internal resistance. So I'll have minus, and then we will have 95 ampere multiplied by small r. Good. And so we'll have 95 small r is equal to 12 minus 8.2. 12 minus 8.2, that will be 3.8, right? So I have 3.8. And so the internal resistance here, we can divide both sides by 95. So we'll have 3.8 divided by 95. And we will have 0.04. So I have 0.04 ohm here. And so the resistance of the starter here is this one, or I can rewrite this as 86 milliohm. And here the internal resistance of the battery, that will be 40 milliohm. Okay, and then the internal resistance is this one that I highlighted gray. But then the resistance of the starter is this one here that I highlighted blue. So I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. And thank you for watching. See you in the next video. Bye bye.